Okay, so we have our position versus time graph here. So one of the things that you guys are going to have to be able to do is explain in words how the object moves over this 8-minute period. So I'm going to tell you guys to break this down into separate lines here, separate parts of the motion. So from here to here, before there's any change in position or how speed he's moving or velocity, we're going to just give them a number. So 1, 2, 3, 4, and 5. So in the first line segment, okay, remember, position time graph, guys, it's not like you're going up a hill because you'd be walking up and to the right, which we can't graph. So it's only left and right motion. So basically think about positive slopes, meaning you're going to go to the right. Negative slope, you're turning around, you're going to the left, okay? So 1 moves at would you say, am I moving at a constant velocity here? Yeah, right, because I'm moving to the right and my slope is not changing. All right, constant velocity to the right. What about 2? Now, could I be more detailed? If you wanted to, you could say, yeah, I moved from 0 to 100 in 2 minutes. So I moved, you could have said, I moved 100 meters in 2 minutes going to the right, or I could have said 100 divided by 2. You could have said I'm moving at 50 meters per minute to the right, but this is also acceptable. Constant velocity to the right. Line segment 2. What's good there? What are you doing? Let me ask you this. Are you changing your position at all? Am I increasing where I am or decreasing where I was? No. Nope. So, not moving. No way. What about 3? What would you guys say about 3? Okay. There's no curve to the slope, so it's constant velocity. To the right. And then I would just add, is it slower or faster than line segment 1? So I'm just going to write slower than 1. So hopefully you understand what I'm talking about there, right? So remember, guys, steepness is relating to our speed or velocity. The steeper it is, the faster it is. All right, 4, what's good at 4, guys? Correct. Not moving, at rest, okay, because there's no change in position. But 5, oh boy, what's good at 5? Good. Constant velocity. Now, because it's moving in the negative direction, we're going to say, all right, it's moving now back to the left. Okay, so constant velocity. Would you say that's pretty slow or quick? Like, would you say 5 is slow or fast? Remember, the more flat it is, the slower it is. The more steep it is, the faster. So 5. Would you say 5 is steep or kind of more flat? Steep. So since it's pretty steep, 5. All right. Constant velocity. We could say high speed or constant velocity. We'll say to the left. Moving fast. Okay, so there we go. We explained our time. Now that's cool. That's great. Now you have to use the graph here in order to determine, all right, our velocities. Now our answers are going to be in meters per minute, not meters per second, because right now they have time in minutes. Okay, distance or position here is in meters. So again, your equation that you would need, velocity is displacement over time, or final position minus initial position divided by the time. So how do I know what is my final position and initial position? Well, for line segment 1, where am I starting? At 0 time, what is my position? 0 meters. All right, at the end of my line segment 1, guys, what is my position? 100. How long was I moving for? How many minutes? Line segment 1 starts at 0 and finishes at 2 minutes. So T is equal to 2 minutes. So the equation will be XF minus XI divided by the time. So XF is 100 minus the initial position divided by the time of 2. 100 divided by 2. So it'd be 50 meters per minute. All right. And we're going to kind of go through and finish those. Now, I'm going to show you guys how to do the average speed for the entire trip. So average speed, even though I wrote it on the front side of this, I don't have it here. So average speed is your total distance over the total time. All right, so Mr. Lombardo, cool. How do I freaking determine that from the graph? All right, so the easiest way that I do it, guys, you can break it down per line segments. In line segment 1, guys, how far did you move? You went from 0 to 100. So I would say, okay, I moved. Actually, I'm not going to do it in this. I'll just do it up here. So line segment 1, I'm just going to write 100 meters. Line segment 2, did you change your position at all? No, we said we're not moving, so we don't need to worry about that. So you could say, okay, that's 0. What about line segment 3? You're at 100, and you go up to 150. So 100 to 150, how far? 50 meters. Line segment 4, we didn't move, so 0 meters. And what about 5? So line segment 5, we start here, which means we're at 150, and we end right there. And if we go across, that means we're at 50. So if I went from 150 to 50, how far did I just move? 100 meters. And so to do the total distance, now you add them all together. 100 plus 0 is 100, plus 50, 150, plus 0, still 150, plus 100. So distance would equal 250 meters. But what about your displacement? Remember, delta x, what is that? Final minus initial position. So if we're looking at the whole thing, at the very end, where's the last piece of the line segment? Right here, right? And now that's at the 8-minute mark. So if I go across, where am I at the very end? My XF would be 50. That's an ugly 50. Jeez. And what would my initial position be? Where I started the whole trip, which is 0. So my displacement is 50 meters. Okay, so that 250 will be down here for your total distance. And how long was the whole trip? 8 minutes. So 250 divided by 8 minutes. So, what is it? Just 31 flat? Or 31? 31.25. Okay, so we're going to have 31.25 meters per minute. Okay, and then to calculate average velocity, again, velocity will be your overall change in position, which is displacement, over time. We did that up to the top. We figured out what our final position was, which is only 50, and our initial position of 0. So when we subtract them, we get 50. So our displacement is 50 meters. Total time, 8 minutes. All right, and then you do 50 divided by 8. Good. 6.25 meters per minute. Now you guys will have to find these guys here. 2 of them should be 0, which would make sense because you don't change your position. So the average velocity for 2 and 4 should be 0. 3 should be positive. And average velocity for number 5 should be negative because it changed direction. Okay? Velocity is basically speed with direction. So you can have a negative velocity, but never a negative speed. Okay? So make sure you guys finish this, please.